Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 6, Lesson 1 on equations and their solutions. So in this unit, we're going to really start to dive into some algebra, all right? And maybe the most important idea in all of algebra is the idea of an equation and then solutions to an equation. So before we even talk about like how to solve an equation or what a solution to an equation is or anything else, let's make sure you understand what an equation is. Let's do it. Here we go. So, a mathematical equations, right? An equation, all it is a statement about the equality of two expressions. That's it. Just, we talked about expressions in the last unit, right? We even evaluated expressions when we were given values of variables. But at the end of the day, all an equation is a statement about the equality of two expressions. Now, that statement could be true. Do you know what I mean? Like I could say, hey, I'm older than 40. That's a statement about my age, right? And it's true, right? But the statement about equality could be false. I could say, hey, I was a pole vaulter back in high school. That would be false. That would be a lie, right? Or it could be open, which just basically means I can't tell whether the equation is true or false. So that's where we start. We just start with an idea that an equation is a statement about the equality of two mathematical expressions. And that can be true, false, or open if we can't tell. So let's jump into exercise number 1, where we simply are going to look at this issue. Here we go. Exercise 1. State whether each of the following equations are true or false. Justify for those equations other than A and B. All right. So, obviously, right, we can look at equation A, 10 equals 10, and we can say without a doubt that that is true. Right? There's no question that 10 is equal to 10. It's true. All right, great. I didn't lie. Right? On the other hand, letter B, 18 equals 5. Pretty sure, even on its best day, 5 doesn't equal 18. So that's false. But there is absolutely no reason why we can't have more complicated equations. For instance, in letter C, this one says 4 plus 7 is equal to 19 minus 5. Well, the question is that a true statement or is that a false statement? And really, the best way to figure out whether it's true or false is to simply evaluate what the left-hand side of the equation is equal to, evaluate the right-hand side of the equation, and see if they're equal. So 4 plus 7 is obviously equal to 11. 19 minus 5, I think I'll stop putting the equal sign there. 19 minus 5 is equal to 14. And so that is a false equation, right? 4 plus 7 doesn't equal 19 minus 5. As simple as that. Now, F, G, and H, these are more complicated. They have exponents in them, parentheses. We even have an absolute value and a fraction all in the same kind of statement. And yet, it still boils down to, does the calculation on this side, does the value of that expression equal the value of that expression? If so, the equation is true. If not, the equation is false. So even though it involves some more, higher level math, if you will, I'd like you to pause the video now and see if each one of these equations has a value that's true or a value that's false. Pause the video now. All right, now that likely probably took you a little while. Okay, and I hope you did kind of work through each one of them. If you need more paper, never hesitate to grab scrap paper to do your math on. All right, so here we go. Let's take a look at letter F. Now, order of operations tells me in letter F that I first need to figure out what 8 minus 2 is, and that's pretty easy. That's 6. Okay, on the right-hand side, order of operations tells me I first have to figure out what 7 squared is, which is 7 times 7, and that's 49. All right. Now working back on that left-hand side again, I've got 5 times 6. Remember, that's what it means for those two numbers to sit by each other, and that's equal to 30. And then I have 49 minus 19, which is also equal to 30. So that is a true equation. All right, so not too bad. Had a little product here and a little squaring and subtracting there. Let's get into one which is kind of similar, letter G. Right? Here I've got to look at this side. I have to remember my order of operations, which says to do this product first. 4 times 8 is 32. I'll deal with the minus 7 in a little bit. Right? On this side, I have to do each one of these exponents first. So I have to do, 3 times 3, and I have to do 4 times 4. So 3 times 3 is 9. 4 times 4 is 16. Now, on this side of the equation, I can say 32 minus 7, that's 25. And 9 plus 16, that's also 25. So that is also a true equation. And by the way, if you're wondering to yourself, what happened to that whole open equation thing, we're going to address that in the next exercise. But let's now take a look at the beast, right? Let's go through this one. All right, in this particular problem, right, we've got the absolute value of negative 20. Well, remember, the absolute value of a negative number is just the sort of positive version of it. So the absolute value of negative 20 is 20. And then I'm going to evaluate 2 times 4, which is 8. On this side of the equation, I've got 6/5 of 15. 1/5 of 15 is 3. So 6 times 3 is 18 minus 5. We have 20 minus 8, which is equal to 12. We have 18 minus 5, which is equal to 13. And so that is a false equation. There is no close enough, right? So 12 isn't close enough to being equal to 13 to actually make that equation true. An equation is either true, false, or if we can't tell, open. And let's now kind of address that issue in the next set of problems. All right, here we go. Exercise number 2. Consider the equation x plus 5 equals 12. Letter A, an equation is open when it is unknown whether it's true or false. Why is this equation open? All right, well, write down why I would consider this equation to be open. Go ahead and do that. Well, simply put, it's open because we don't have a value for x. Or how about this? We have not been given a value of x. Once we're supplied a value of x, then we can judge whether x plus 5 is equal to 12, in which case it would be true, or whether x plus 5 is not equal to 12, in which case it would be false. Now, letter B says, if x is equal to 4, is this equation true, false, or open? Explain. All right, well, why don't you go ahead and figure out, given now that x is equal to 4, is the equation true, false, or open? Pause the video now and decide. All right, well, in order to figure out true, false, or open, we're now going to take x equals 4 and we're going to substitute it into the left side of that equation, or anywhere that x is. So once x is equal to 4, we can substitute it. So 4 plus 5 is equal to 12, 9 is equal to 12, and the answer then is that the equation is false. Okay, now let's think about letter C a little bit. What value of x would make this equation true? Explain. All right, so we know x equals 4 is making this equation false because 9 doesn't equal 12. So the question then in C is, what value of x, if any, would make this equation true? See if you can just think about the equation and figure out the answer for x. All right, well, hopefully it's not that difficult. And hopefully it's not that difficult because you can say, well, what number, when I add 5 to it, would equal 12, right? I mean, that's ultimately what this is saying. What number, when I add 5 to it, would equal 12? Well, that would be x equals 7, right? And the reason why is that 7 plus 5 equals 12, right? 12 equals 12, right? So it's a solution because, it makes the equation true because it, when added to 5, is equal to 12, right? So what we see, right, is that when we have an original equation that's open, right? And this equation is, just on the face of it, open. Then there are some values of x that make it false, and there's at least one value of x in this case which makes it true. And that brings us to maybe the most important idea in all of algebra. Wait, let me say that again. This simple exercise brings us to probably the single most important idea in all of algebra: solutions to equations. For equations that contain variables, and not all equations contain variables, look back at exercise number 1, right? But for equations that contain variables, a solution of the equation is any value of the variable, or variables if there's more than one, that makes the equation true. So if a value of x makes an equation true, or a value of c or m or n or whatever the variable is, if it makes the equation true, it's a solution. If it makes the equation false, it's not a solution. So in our last exercise, where we had x plus 5 equals 12, 4 was not a solution, but 7 was. All right? Again, the most important idea in all of algebra. If a value makes an equation true, it's a solution. And if a value does not make the equation true, it's not. So let's use that in exercise number 3. Determine if each of the given values is a solution to the given equation. Justify. All right, this is awesome because we've got a test, right? If I take 12 and I put it in this equation and it makes it true, then it's a solution. And if it makes it false, it's not. So this is actually quite simple, right? I'm going to take my 12. I'm going to substitute it into the equation. 12 plus 10 is equal to 22. 22 is equal to 22. That's true, so the answer is yes. Right? The question is, was it a solution? The answer is yes, because it made the equation true. Some teachers will say it makes the equation check. In other words, oh yeah, I can, 22 equals 22, check, right? But I really want to boil it down to true and false. Is 22 equal to 22? Yes, and therefore 12, which made this thing true, is a solution. Could there be other solutions? Possibly. But all we know for certain right now is that 12 is one of those solutions. All right, let's keep playing around with this. Let's try this one, right? Where I have y minus 7 is equal to 11, and I want to see if y equals 20 is a solution. So I'm going to do exactly the same thing I did before. I'm going to take that 20, I'm going to substitute it in for this y, right? And I'll get 20 minus 7 is equal to 11. That gives me 13 is equal to 11. That's false. And therefore the answer is no. That is not a solution to the equation. All right? So at the end of the day, right, this is simply a true-false question, right? If true, the answer is yes. If false, the answer is no. What I'd like you to do now is play around a little bit with C, D, E, and F. Don't forget things like your order of operations and what we learned in the last unit in terms of evaluating expressions, right, when you substitute variable values in. But see for each one of these whether the supplied value of the variable is a solution or not to the equation. Pause the video now and take a few minutes to do this. It's going to take a little bit. All right, well, letter C and letter D are relatively easy because they're kind of, if you will, one step, right? So in letter C, what we find is that when we take 7 and we plug it in for C, we'll get 3 times 7 is equal to 18. 21 is equal to 18. That is false. And so the answer is no. That is not a solution. All right. Oh, there's a lot more of them than just D, E, and F, right? We have a whole nother batch of them down here. All right, so we'll go through these and we'll have you work on these a little bit on your own. Anyway, let's take a look at these. So in this one, I'm going to take 28, plug it in for W, and I'm going to get 28 divided by 4 is equal to 7. Never forget that this is going to be very important for us, is the same as this. 28 divided by 4. 28 divided by 4 is 7. That's true. And so the answer is yes. All right, let's take a look at letter E. Now, here's where they start to get a little bit more complicated because you have to worry a little bit about your order of operations. In the first 4 that we looked at, there was a single operation that was done to the variable, so as long as we understood our operation that was being presented and we were able to calculate it correctly, then no problem. Here it gets a little bit dicier, so let's kind of make sure that you have it. I want to make sure to check to see whether 5 is a solution, so I'm going to plug it in for x. I'm going to put that in parentheses. Right? Now, absolutely key here, right? We have to know that in this calculation, order of operations tells us that I must do this multiplication first, then this addition. So I'm going to have 15 when I do 3 times 5, plus 7 equals 22. And that, in fact, does equal to 22, so that's true. And therefore, the answer is yes, that is a solution. All right, let's take a look at letter F, right, where we have additional division going on here. Again, I want to take my 34 and substitute it in for y. Right, when I do that, I'll get 34 minus 4 divided by 5 is equal to 8. That's going to be 30 divided by 5 is equal to 8. 30 divided by 5 is 6. 6 is equal to 8. That is most certainly false. So the answer is no. That is not a solution. Right? Kind of nice. Now, I didn't realize that these problems were on the sheet as well. So I want to make sure that you have ample time for that, but I want to point out a few things before we move on. In each one of these 2 cases, the variable shows up more than once. That's fine. Remember, you're just going to replace the variable with the value that's supplied and see if the left-hand side is equal to the right-hand side. Here, the variable only shows up once, but then we have like a little bit of cubing, third power there. So what I'd like you to do again is pause the video, take a few moments, work through these. Let me kind of bring them up here so we have a little more room, and then we'll go through them to check to see whether those values are solutions or not. Pause the video now and take a few minutes. All right. Let's go through letter G. The first one where we had a variable show up on what's known as both sides of the equation. The sides of the equation are divided by that equal sign. So you have the left side, the right side. Anyway, so we're going to put the 5 in for x on the left, and then the 5 in for the x on the right. Again, order of operations says we have to do the multiplication first. 6 times 5 is 30. We'll do that subtraction in the next step. 4 times 5 is 20, right? 30 minus 8 is 22, and 20 plus 2 is 22. So that's true, and therefore the answer is yes. That is a solution to the equation. All right? Again, letter H, if this is sounding very, very like rote, it's because it's important. Remember, the most important idea in all of algebra. So now I'm going to take 18, I'm going to substitute it in for this f and for that f. Let's see what we get. So we're going to get 18 divided by 6 plus 5 is equal to 18 minus 8. 18 divided by 6 is 3. 18 minus 8 is 10. 3 plus 5 is equal to 8. 8 does not equal 10. That's false. And therefore, the answer is no, not a solution. And now our final one that involves exponents. So here we go. I'm going to put the 2 in for the n, right? So I'm going to have 2 cubed. Now keep in mind, order of operations says we have to do this exponent first. And if you can't do that in your head, then maybe you come down here on your paper and you go 2 cubed is 2 times 2 times 2. 2 times 2 is 4. Times 2 again is 8. So 2 cubed is 8. That means we have 5 times 8 is equal to 40. 5 times 8 is 40. So that's true. And the answer then is yes. Remember, ultimately speaking, each one of these had a yes-no answer. Yes, it was a solution, or no, it wasn't. So yes, 2 is a solution to this equation, but no, 18 is not a solution to that equation. And again, it's very simple. And what this really gets to is the fact that in the coming lessons, we're going to see some techniques to actually produce the values of the variable that are solutions to the equation. But mistakes happen. right? We can make a mistake in what we do, but never forget that by taking the value of the variable and substituting it back into the equation, you can see whether or not you actually have a solution to the equation. All right? So let's keep going. One more here. Exercise number 4. Which of the following values of x is a solution to the equation 3x minus 7 equals 26? Now, we've given you absolutely no techniques in order to solve an equation. All right? And in fact, this type of an equation you won't even solve until Math 7, not Math 6, because this is what's known as a two-step equation. So the only way you have of deciding which one of these 4 choices is a solution to this is by literally saying to yourself, think about order of operations, which of those 4 numbers, when I first multiply by 3, and then I subtract 7, will give me 26. Which one will do that? So I'd like you to pause the video now, play around with these 4 choices, and see which one of them, after you multiply by 3 and subtract 7, gives you 26. Pause the video now. All right, well, let's actually go through one that's wrong. All right, so for instance, this is not the right answer, right? If I took 10 and I plugged it in to this equation, substituted it in, right, I'd get 7 times 10, which is 30, minus 7 equals 26, and then that would be 23 equals 26, and that would be false, right? And what that would tell me is that the correct answer is not 10, right? That is not a solution to this equation. So if I do that on the 3 other choices, what I'll eventually find is that choice 3 is in fact correct. And the reason why, if I take the 11 and I substitute it in for x, right, then I'll get 33 minus 7 equals 26, and I'll get 26 equals 26, and that is true. So x equals 11 is a solution to this equation. All right, let's wrap this lesson up. Now, we saw 2 very important ideas. In fact, the 2 ideas that form the absolute basis of all algebra. One, the idea of an equation all on its own, right? An equation just being the statement about this expression equaling this expression. That statement could be true, it could be false, it could be open if we don't have a value for a variable, all right? But then, maybe even the more important idea is the idea of a solution to an equation. The value or values of variables that make the equation true. All right? So the homework tonight, I really want you to work hard on making sure whether you can tell whether an equation is true, false, or open, and whether or not a supplied value of a variable is a solution to the equation. We'll work with that more obviously in upcoming lessons. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.